Section 5.3 deals with exponential functions again. This time it's going to be more in the form of story problems and questions involving investments and things. So our first example here is investing $500 at 10% compounded monthly for 6 years. And our formula for this would be taking your initial value, which we'll call the principal, and then 1 plus the percent over the number of compounds in a year. And then the exponent is going to be the time multiplied by the number of compounds. So in this instance, you would have 500 and 1 plus 0.1, and since it is monthly, it would be over 12. And then since it is for 6 years, that would be 6 times 12 for your exponent. When you enter this into your calculator, this part of it you need to make sure, depends on what type of calculator you have, but when you use your exponent key, if it doesn't put the exponent up like it does here, and you have a calculator that does this, make sure you put the 6 and the 12 in parentheses. Otherwise, it's going to take it to the 6th power and then multiply by 12 if you do not do that. And so when you do this, you will get an answer of $908.79. Now, the other type of question that you're going to get, let's go back to this one for a moment. Here, the number of compounds, if it's monthly, if it said it was quarterly, then this number here would be a 4, and that would be a 4. Other ones could be daily, which would then be 365. Could be semi-annually, which would be 2. Which then leads us to this again, except we're going to take out the monthly, and we're going to say it's compounded continuously. If that is the case, your equation would be 500 times 1 plus 0.1 over infinity, because it's compounded all the time, to the 6 times infinity. Well, that you can't put in your calculator. But we know that this (1 plus 1 over infinity to the infinity) is equal to the value of E. And E is a button on your calculator. I think it should be the shift of ln. And E is approximately equal to 2.7182 and a bunch of other stuff. It goes on forever. And so to change this formula, it would become this. TE to the RT. So for this particular one, it would be 500 E to the 0.1 times 6. And again, some calculators, when you use your E button, will just give you this. Others will give you that, and maybe even the parenthesis. Others may just give you that. If you're going to put 0.1 times 6 in there, just make sure you enclose it in parentheses, no matter which type you have. Or if you want to do the math in your head beforehand, you can do that as well. And so when you do this, it would become $911.05. And And that basically is most of what the chapter is about, that section. One other thing that you need to understand about a function like this, 3e to the x, this would be an exponential growth function. Because that value is greater than 1. And so when you drew the graph of this, it would go like so. That right there would be 0, 3, because it's our initial value. If we turn that around and we put 3e to the negative x, now that's going to be an exponential decay function. That's going to go like so. Still going to be 0, 3. But because that's a negative, you have to take the reciprocal of e, which would be 1 over e, which is approximately equal to 1 over 2.7. And that would conclude this section's lesson.